Hello everyone. In this video, we'll be covering concepts from the course of Chemistry 1411, also known as General Chemistry 1. The topics we're covering today are going to be redox reactions and oxidation numbers. So a redox reaction, or a oxidation reduction reaction, is a type of chemical reaction that involves a transfer of electrons between two species. We can tell there has been a transfer of electrons if there is a change in the oxidation number between the reactant and the products. So let's go over oxidation and reduction before we cover the oxidation numbers. Oxidation is going to be the loss of electrons or an increase in oxidation state by a molecule, atom, or ion. Reduction is going to be the gain of a electron or the decrease in oxidation state by a molecule, atom, or ion. The way that we can remember these are by the two different kind of ways to remember it is going to be oil rig, which is oxidation is loss, which is oil, and reduction is gain, so gain of electrons or loss of electrons, or we can say, Leo the lion says grr. So, sorry, that's supposed to say of. Loss of electrons is oxidation, so LEO. And grr is gain of electrons is reduction. So gain E, electrons are reduction. So that helps us kind of remember what is happening in my equation. But to be able to figure that out, we have to know oxidation and the numbers. So again, before we hit it, we're going to talk about oxidizing and reducing agents. An agent makes something happen. So for example, if we have a movie star agent, they're going to help the actor get into movies. So it's going to be the same thing for oxidizing and reducing agent. An oxidizing agent makes oxidation happen. So it's making it happen. A reducing agent makes reduction happen. So let's look at the picture right here. So we're giving electrons from A to B. So B is gaining electrons from A, which means that, remember, redox, or oil rig, or Leo the lion says grr, when you're gaining electrons, it's being reduced. B takes electrons from A, which is oxidizing it. So B is going to be the oxidizing agent. So if I'm reducing, then I am the oxidizing agent. And then let's look at A. A loses electrons, so it's going to be oxidized. A gives electrons to B to reduce it, which means that A is the reducing agent. So if I'm oxidized, I'm the reducing agent. So you can kind of think about it like they're double agents. So if I'm reducing, I'm the other person's agent. So reducing is oxidizing agent, oxidizing is reducing agent. And we'll be able to see this more as we work through a couple examples. But before that, we have to talk about oxidizing or oxidation numbers. Oxidation numbers are hypothetical numbers assigned to an individual atom or ion present in a substance using a set of rules. Oxidation numbers, or oxidation states as they're also called, can be positive, negative, or zero. It's very important to remember that oxidation numbers are always reported for one individual atom or ion and not the group of atoms or ions. So let's go through some of the rules. The oxidation number for an atom in its elemental form is always 0. A substance is elemental if both of the following are true. Only one kind of atom is present. So if I have hydrogen, even though it's just hydrogen, like it's 0. However, H2 is also one type of atom. So H2 is also in elemental form. So its oxidation number will also be 0. So when you see that, you'll know that it has to have the oxidation number of 0. So right down here we have a couple examples. You sometimes see S8. Even though it has 8 sulfur, it's only one type of atom. So it's still going to have an oxidation number of 0. Fe, there's only one, it's 0 as well. Rule 2, the oxidation number of a monatomic ion, so something that has a charge, so H plus 1, the charge of the monatomic ion is going to be its oxidation number. So for example, we have S2 minus. The oxidation number for that is -2. The oxidation number for Al3 plus is going to be +3. So whatever its charge is going to be its oxidation number. The oxidation number for all group 1A metals is going to be +1 unless it's in elemental form, which would be 0. The oxidation number for all group 2A metals is going to be +2. Just like before, unless it's in elemental form, then it is 0. Hydrogen has 2 possible oxidation numbers. When it's with a nonmetal, it's going to be +1, and with it's a metal, it's going to be -1. So really pay attention to whether something is bonded to a metal or nonmetal. Oxygen has 2 possible oxidation numbers as well. The most common is going to be -2. That is pretty much what you're going to see most of the time. However, if it's with a peroxide, so it's O2 minus or H2O2, that is a peroxide, it would be a -1. Rule 7, the oxidation number for fluorine is always going to be -1. So remember that. Rule number 8, the sum of oxidation numbers of atoms or ions is going to be neutral. So whenever you're adding, you have a compound, you assign the oxidation numbers for everything, it needs to balance out to 0. The only time that's different is going to be when you have a polyatomic ion. So that brings us to rule 9. The sum of the oxidation numbers of all atoms in a polyatomic ion is going to be equal to the charge on that polyatomic ion. So for instance, if I have SO4 2 minus, when I add all of my charges together for that, sorry, not charges, oxidation numbers, when I add all those oxidation numbers together, it should equal -2. So it's going to equal whatever the charge is on that polyatomic ion. So I'm going to show you a brief video where they're going to talk a little bit more on oxidation numbers.
In this video, we're going to learn how to figure out the oxidation numbers for the different elements in a chemical compound. The oxidation numbers are the numbers that I've written here above each one of the elements. Now, if you want to learn more about what oxidation numbers are or why they're important, check out my video called What Are Oxidation Numbers? In this video, we're going to work through the process of how you figure out what these numbers are. So here are the rules that we're going to use to figure out oxidation numbers. Now, just so you know, every teacher and textbook has their own version of these rules, but they all work in pretty much the same way. So if you learn mine, you'll still get the answer right 100% of the time, even if these are a little bit different from your teacher's. I'm going to talk through a few of these rules right now, and then I'll introduce the rest just as we work through practice problems. The first is this. An element by itself always has an oxidation number of 0. Here's what I mean by that. There are a lot of chemical compounds that have just one element. That element is not combined with any other elements. That's what I'm calling an element by itself. So that's something like Cl2. It doesn't matter how many atoms of that element you have, just as long as it's only that element and none others. So Cl2, an element by itself, oxidation number of 0. Sodium, Na, by itself, 0. S6, just sulfur, nothing else. P4, phosphorus, and nothing else, 0. So that's probably the easiest rule here. It's always 0 for the oxidation state if you have an element by itself with nothing else. The other rule here is about monatomic ions. These are ions that are made of only one atom. So like this. For monatomic ions, their oxidation number is the same as their ion charge. So for K plus here, its oxidation number is going to be +1. For N3 minus, it'll have an oxidation number of -3, and Mg2 plus here is going to have an oxidation number of +2. Now keep this in mind, when we write oxidation numbers, we write the sign first, so plus, minus, and then the number after. This is the opposite of how we write ionic charges, so just keep that in mind. The charge might be 2+ on magnesium, but the oxidation number is +2. Now for the rest of these rules, we usually use more than one together. So I'll just talk about these as we use them in example problems. Here is our first example. KCl, we want to figure out the oxidation numbers of the elements in this compound. Okay, so let's take a look at our rules here. K, potassium, is in this column in the periodic table. It's in group 1A. So there's this rule that elements in group 1A are always +1. So that is potassium's oxidation number. Then we have Cl over here. That is one of the halogens. Halogens, usually -1, positive with oxygen. Well, Cl certainly isn't with oxygen here, so we'll give it a -1 oxidation number. Now, I want to use this to show you a third rule. That's this rule right here. The sum of oxidation numbers for a neutral compound equals 0. KCl is a neutral compound here. It doesn't have a charge after it. So that means that the sum of these oxidation numbers is going to equal 0. And that's definitely true here. +1 minus 1 equals 0. We'll use this later on when we do other examples, but just keep that in mind. The sum of oxidation numbers for a neutral compound should always equal 0. MgO. Mg is in this column in the periodic table, group 2A, and group 2A elements are always +2. So there's that. Oxygen here, we have a rule for oxygen. It is usually -2. It is -1 in peroxide. H2O2 hydrogen peroxide is the most common peroxide. It's probably the only one you'll ever see. But anyway, this oxygen is definitely not in hydrogen peroxide, so it's fair to say that its oxidation number will be -2. +2 for Mg, -2 for O, and they add together to make 0 because this is a neutral compound. CO, carbon monoxide. Let's figure this one out. Okay, so C here, there isn't any rule for carbon. So we'll have to figure it out based on what we do know. Okay, so we do know oxygen. Oxygen is usually -2 unless we're in a peroxide, definitely not a peroxide. So we can safely say that oxygen's oxidation number is -2. Now, let's use this other piece of information that we know, and that's the sum of oxidation numbers for a neutral compound should equal 0. So whatever carbon's oxidation number is should add together with oxygen's to make 0. So we can figure out that carbon's oxidation number should be +2. -2 from oxygen gives us 0. NH3. Okay, N, there isn't any information about that. So just like in the last example, we'll have to figure out its oxidation number using what we do know. Here we've got hydrogen. There's a rule for hydrogen. Hydrogen is +1 with nonmetals and -1 with metals. So nitrogen is definitely a nonmetal, which means that in this case, hydrogen is going to have a +1 oxidation number. Okay, but there are 3 hydrogens. Each one of them has a +1. So what we have to do is we have to multiply this +1 times 3 for the 3 hydrogens, and that's going to give us +3. Now, let's keep this rule in mind, that the sum of oxidation numbers for a neutral compound should equal 0. NH3 is definitely a neutral compound. We don't see any charge here. So whatever nitrogen's number here is, needs to add together with +3 to make 0. So that means that nitrogen here has to be -3. That adds there to get 0. So its oxidation number is -3. Hydrogen's is +1. CaC2. So calcium here is in this column, group 2A. So we know that its number is always +2. We don't know what carbon's number is, but we can figure it out. What we do know is that calcium's number plus whatever carbon's number is needs to equal 0 because this is a neutral compound. It doesn't have a charge. That means that the total number on carbon is going to be -2. But there are 2 carbons here. So we have to divide this number between the 2 of them. So we're going to take this and divide it by 2 to get an oxidation number of -1 for each one. +2 for calcium, -1 for carbon. NO2 1-, check this out, it is an ion. So this is going to be a little bit different. In this case, the sum of oxidation numbers for a polyatomic ion equals the ion charge. So let's see how we'll use that here. Nitrogen, we don't know what its oxidation number is going to be, but oxygen here is usually -2. So we have -2 here, but we have 2 oxygens. So we're going to do -2 times 2 is going to give us -4 altogether. Now, whatever nitrogen's is, when we combine it with -4, we need to get not 0, but we need to get -1, because that's what the ion charge of NO2 1- is. So this means that we will have 3 plus 3 plus 3 minus 4 gives us -1, which means that the oxidation number here on nitrogen is going to be +3. HNO3. Okay, let's take a look at the rules. We got hydrogen. Hydrogen here is combined with nonmetals, nitrogen and oxygen, so that means that its oxidation number is going to be +1. Oxygen over here is going to be -2, but we have 3 oxygens, so we got to take this -2 times 3 to get -6. Okay, so now we have +1 from the hydrogen plus whatever nitrogen is, -6 has got to give us 0 because this is a neutral compound here. So that means that in this case, nitrogen's oxidation number will be +5. 1 plus 5 minus 6 equals 0. Now I'm going to start talking about some more challenging examples that use some...
All right, so I'm going to stop right there so that we can get back to our PowerPoint presentation. All right, so we're going to use the application of our problem. So it says the thing that is oxidized is the reducing agent, just as a reminder, and the thing that is reduced is our oxidizing agent. So let's look at Ca plus Cl2 yielding CaCl2. We assign the oxidation number, so Ca is an element, so it's 0. Cl2, we only have 1 element, so it's 0. And then we go to our rules. So Cl2 is going to have a -1 charge. We have 2 of them, so we get -2, and so Ca has a +2 because it needs to equal 0. So we look, what we're going to do is compare the oxidation numbers between the Ca's and the Cl's. So Ca is going from 0 to +2. So remember, electrons are negative. So becoming more positive means you're losing electrons. And when we lose electrons, we're oxidizing. So calcium is going to be oxidized. When we have chlorine, we're going from 0 to -1. So we're gaining electrons, which means that calcium is reduced. So if chlorine is oxidized, it means that, if calcium is oxidized, calcium is our reducing agent. And if chlorine is reduced, chlorine is our oxidizing agent. So that is kind of how you have to look and break down the pieces to the redox reactions that you're looking at. So let's go through an example. It says determine the oxidizing and reducing agents for the following. We have HNO3 plus H2S yield S plus NO plus H2O. So let's go ahead and go to our boogie board and we'll work through this example. So let's go ahead and first write out what our equation is. So we have HNO3 plus H2S yields S plus NO plus H2O. So we can go ahead and one by one start to determine the oxidation numbers. So hydrogen has a rule. It is +1. Oxygen, it's not in a peroxide, so it's -2. But we don't know what nitrogen is, so when we get them to add up to 0, so 2 times 3, that's going to give us -6. +1, so -5. We need to get to the 0, so N has to be +5. Come over here, hydrogen again is +1. We have 2 of them, which gives us +2, so sulfur has to be -2. Sulfur here is in elemental form, so it's 0. Oxygen, -2, which means nitrogen has to be +2. Hydrogen is +1, there's 2 of them, and oxygen is -2, that will equal 0. So now we have assigned all of our oxidation numbers, and we need to compare them. Our hydrogens, we notice, aren't changing. Every time it's going to be +1. So we know that hydrogen isn't going to be part of our redox reaction. However, we notice that our nitrogen is going from +5 to +2. So it's decreasing in oxidation number, which means it's increasing in electrons. So nitrogen is gaining electrons. And when you're doing them, you're not going to just write nitrogen. You're going to write the compound that it's in. So you say HNO3 is gaining electrons. I'm going to write electrons as that, which means that it is reduced. Our next one that we can look at is sulfur. Our sulfur is going from -2 to 0. So we're going from -2 to 0. Sorry, it's a really ugly line. Which means that H2S is losing electrons because it's becoming more positive. And so when it loses electrons, it is oxidized. All right, so now we know which one is oxidized, which one is reduced. So we can say that because H2S is oxidized, it is the reducing agent. And because HNO3 is reduced, it is the oxidizing agent. And that answers our question. So now we can move to another example. Determine the oxidizing and reducing agent for this one. So we have MnO2 plus 4HCl yields MnCl2 plus Cl2 plus 2H2O. So let's go over here and we'll write all that out again. So we have MnO2 plus 4HCl yields MnCl2 plus Cl2 plus 2H2O. And just like before, we're going to assign the oxidation numbers. So oxygen is -2. We have 2 of them, so that gives us -4, which means Mn has to be +4. Cl is -1, H is +1. Cl is -1, there's 2 of them, that gives us -2, so this one has to be a +2. Here, it's by itself, so it's 0. Our oxygen, -2, hydrogen +1, there's 2 of them, so it zeroes out. So what we notice is that our Mn is going from a +4 to a +2, which means that it is gaining electrons, so it's becoming more negative. So our MnO2 gains electrons, and it is being oxidized. Sorry, not oxidized, reduced. Okay, so now we have what is being reduced. If I look at my Cl, I'm going from -1 to 0, so I am becoming more positive, so I'm losing electrons. So HCl loses electrons, so it's becoming oxidized. And so now that we know which one is reduced, which one is oxidized, we can determine which one is which agent. So MnO2, because it is reduced, it is our oxidizing agent. And HCl, because it is oxidized, it is our reducing agent. And that is the answer to our problem. Let's do another. This time, we're not trying to determine what is oxidizing, what is reducing, or which one is which agent. We're trying to determine, is this even a redox reaction? This is a common question that you can see on an exam. So instead of it just giving you one, it can give you multiple equations, and it wants you to determine which of the following is or is not a redox reaction. So we're going to go through and work a couple of these to be able to determine yes or no to whether it is a redox reaction. So our equation was Cu plus Ag2O yields CuO plus Ag. So let's determine the oxidation numbers first. Cu is by itself, so it gets a 0. Oxygen is -2, which means the Ag, because there's 2 of them, has to be +1. Over here, -2, +2, and then 0 because it's by itself. So Cu is going from 0 to +2, and Ag is going from +1 to 0. So this is becoming more positive, so it's losing electrons. Which means because it is losing electrons, it is oxidized. And then Ag is becoming more negative because it's going from +1 to 0, so it gains electrons. So it's reduced. So because we have something that is oxidizing and something that is reducing, that yes, this is a redox reaction. So yes, this is a good reaction. Same thing here. Now we have Cl2 plus 2Ki yields I2 plus 2KCl. So let's determine if this one is a redox reaction. Ignore this. Right there. All right. So Cl2 is by itself, so it's 0. K is going to be a +1, which means the I needs to be a -1. Here it's in elemental form, so it's 0. K is +1, Cl is -1. It's good because it zeroes out. And now we can determine, is anything changing? So Cl2 is going to -1. So we know that because it is gaining electrons, it's becoming more negative, it is reducing. Now we need to see if we have anything that is oxidizing. So what we notice is that I is going from -1 to 0. So it's becoming more positive, which means it's losing electrons and it is oxidized. So we have something that is reducing, we have something that is oxidizing, so yes, this is a redox reaction. Go through a couple more examples here. All right, same thing, so we have NaCl plus AgF yields NaS plus AgCl. So let's go over here, rewrite it, and assign oxidation numbers. So we have NaCl plus AgF yields NaS plus AgCl. So both of these have a rule. So this is +1, this is -1. F is always -1, so Ag is +1. Same thing here. Cl -1, Ag will be +1. So Na is +1 here. It's also +1 here. So far Na is a part of it. Ag +1, +1. It can't be oxidized or reduced. F does not change. It stays at -1. We have nothing that is changing in oxidation number. So this is not a redox. And so you need to be comfortable with being able to assign oxidation numbers to determine if something is or is not a redox reaction. And that pretty much wraps up redox reactions and oxidation numbers. So let's go over a brief overview of everything we covered. So under redox reactions, we covered that oxidation is going to be the loss of electrons, and if it's oxidized, then it is the reducing agent. If something is reduced, it's gaining electrons, which means it is the oxidizing agent. And then we covered oxidation numbers, which kind of falls under redox reactions because you need them to be able to determine whether something is or is not a redox reaction. And we covered all the rules for assigning oxidation numbers. As you saw in the video, there are some ways that are slightly different based off of your professor on memorizing the rules for oxidation numbers. Pretty much they'll all give you the same outcome. It's just very important that you know them. Most professors will not provide them on an exam. So make sure that is one thing that you actually go forth to memorize and practice with before you come to test your testing on it. That is all that I have today. I hope that this video was helpful for you. Thank you for watching.